So I was going to be talking about APIs, but given all the questions that I've had in the first, since I got here, I'm actually going to can this talk. I'm going to do a talk about comparing the state of British Railway with the state of the Dutch railways. And just see, I've had a number of people ask me how I got here, and the comparison between what we have. I spent most of a day yesterday getting from the north of England to London for a conference. Missed 3 trains. If I went before 9 in the morning, it would cost me £480 for a one-way ticket. Right? There's no notifications. You have no idea when trains are cancelled. You've got no facilities on the train. Nothing works. And I got over to Brussels, and everything is just perfect. And even on the app now, I even get a little thing that tells me these trains are busy, these trains aren't so busy. So it's just an amazing experience. We looked at annual season tickets. Over here, what's it, it's about 3,600 per annum. In the UK, people can pay £20,000 for an annual ticket. So you guys got pretty good. So going to be talking here, I heard Martin saying earlier, he's been with OWASP since 2007. Yeah. He's been with OWASP since 2007. I remember my first OWASP event attending. Is that better?
Yeah, should be better.
I'll do that. My first OWASP event was watching Martin talk. Good to be here talking about APIs. So I've been doing DevSecOps, Dev Evangelist, all that kind of stuff, vendors, client-side, consultancy, whatever. It's not a vendor pitch. So why do we need API security? I mean, I think we know this. I'm just going to go through this. So one thing, feel free to interrupt me. We've got a lot of time. I've got a lot of slides, but we can just bolt through them super quick. I'm going to leave time for questions. I know this is a technical audience, so let's do that. We know this, right? We used to own our application. We used to build a 3-tier monolith. We used to control everything, right? Now we've got microservices. Everything is decomposed, breaking down. We're relying on third-party services, which we don't control, and we're selling our services over APIs. Right? Even our man is on the mission now. Supply chain security. We're inheriting risk from our upstream providers, and we're passing that risk down to our customers. And we're doing that mainly through APIs. You know, we know how many API-related breaches. I write a newsletter every week. It's vendor neutral. It's full of breaking new tools that are coming out on API security. That's worth, if you're in the field and you want to keep up to date on anything API security related. It's a pretty good resource set. I hope it's good. It's pretty popular. More or less every week there's an API related vulnerability. So that's how frequent these things are. Right? APIs are becoming so APIs let's do that. Yeah, so APIs are now becoming the number one attack vector because, they're public almost by definition. They're well documented. Right? So they've got a Swagger interface. Everybody knows how to go and use them and exploit them. They are, they're public, and we've got great tools. So you don't need a person. You try to exploit a web application. Right, the API, you can just throw a script against it. You just run a Postman collection. So APIs are easy to attack. And also, attackers now know that the value is in the API. It's not in the web interface. It's in the API that's backing it. Right? So attackers are more frequently turning to APIs. Do feel free to stop if there's questions if people want to. But we know this OWASP, right? Everything comes down to some kind of human error somewhere along the line. Any number of things that developers can do or get wrong. The reason I highlight that is because many of and we're going to look at a bunch of issues that breaches in the last year. And we're going to see that nearly all of the issues would have been preventable. Okay. Just a framework that I use, nothing too fancy there. 6 pillars of 6 domains of API security. Inventory, what you can't see, you can't protect. Design, just the one pitch I'm going to do. We're a shift left security company. We're really into design, shift left, get the design right. and then everything follows downstream. Development, testing, protection, and governance. So we've got the right controls in place. Do we all know the OWASP API top 10? Show of hands. Who knows there is an API top 10, right? And who knows what the kind of difference is between that and the... So we've got the OWASP. I'm going to go through this really quickly. We know what an API is, right? We've got request, authorization layer, authentication layer, authorization layer, API backend, and a response. This is obviously a trivial example. Our friend BOLA, broken object level authorization, is the most prevalent, or it's the most impactful vulnerability. Right, it's the one, there's a classic example of a really good BOLA exploit. The idea with BOLA is some API takes an ID or takes some kind of object identifier, and it's vulnerable to people switching out that ID. The example I spoke yesterday, you log into your Gmail, you've got an identifier, you fiddle that identifier, and suddenly you can access somebody else's object. Right, so BOLA is the number one. It's also the hardest thing to automatically detect. So a lot of the security tools we use aren't great at detecting BOLA. And obviously, the attack is very valuable to attackers because you're able to access somebody else's data quite easily. There's a great example of that. Broken authentication, as it suggests, you've got an API endpoint that is unauthenticated. Sometimes that might be by design, but most often cases, you've copy-pasted a piece of code and you forgot to put an auth decorator on it. Okay, or you fail to adequately implement that authentication. Obviously, a pretty severe vulnerability. Probably the most prevalent, we talk quite a lot about data. So APIs are all about data, right? They're the conduit, they're the pipe through which data is transferred. That type of thing is classic. There's really a number of really good examples. The API returns more data than it should have, right? And there's a couple of reasons for this. One of them is people don't want to keep rewriting APIs to do different business functions. So what do? They write one that returns all the data. And then somebody says, oh, we'll just put that thing on the internet, right? It'll be fine. And then somebody...
Because the front end will just...
Exactly. What can go wrong? There's a couple of really good examples of excessive data leakage. Resource rate limiting, right? Resource protection. Password reset, endpoints. People thrash away at these and reset them. There's some good examples of that as well. So, always put rate limiting and resource limiting. Broken function levels. So this is where you've got functions that people can access that they shouldn't have access to. You have an admin interface that you've got to disable. Somebody finds it, and then they go and do things that they shouldn't do. The other thing is WordPress there's always a WordPress example for something. We've got one in here. Plugins without adequate authorization. So what the plugin did is it checked, is the user registered on WordPress rather than is the user admin on WordPress. Standard stuff that happens every other week. There's something like that. Mass assignment. Think of mass assignment as the corollary of data leakage. Data leakage, you return more information than you should have done. Mass assignment is you interpret access that extra data that you were given. So in that case, that's the canonical example. You have a user registration and somebody guesses, well, I know that they're using XYZ framework. That thing's got a hidden field called isAdmin. They tweak it in there, bang, and it writes it into the database backend, and that person gets isAdmin. So that's the corollary of the excessive leakage. Also pretty serious, that one. And then here we kind of go into the catch-alls, things that are we're more familiar with OWASP. Security misconfiguration, any number of things here. So using frameworks that aren't secured, using endpoints that are exposed, forgetting to put transport layer security on, any of those things. Injection, we still have injection attacks, right? SQL still going strong. Primarily command injection is the most common injection attack that we see now. We see those on router devices. anything that's exposing an admin endpoint. In proper assets management, this comes down to our issue of inventory, right? Knowing what we have. People are running shadow APIs, zombie APIs, right? APIs that they're not tracking, they're not doing version control on them, they're not doing updating them, any number of those bad practices. Logging and monitoring, they're either doing too much logging and committing stuff to logs that they shouldn't, or they're not really monitoring their APIs. So that's the quickest rundown of the OAuth API top 10 that you're going to get. I think we know most of the stuff. A lot of that is obviously very common with what we see in OWASP, but there's those special cases that we've got there, and those are normally the ones that we've got to look out for. So, I would always normally say to an audience, I would make the statement that API security is very different to web application security. Who thinks that's a true statement? And who thinks they're very much the same thing? So let's go with the true statement. Now, so I mean it's quite a controversial topic in the market. Is API security different? I think it's pretty different because we'll come to tools in a second. So the other thing is that a lot of tools that you use, when you speak to people and they say, what tools are you using? People are still reliant on SAST and DAST as we know it to be able to do API security. If you've worked with Spring Boot microservices and you've got lots of little microservices, scan that with whatever your favorite SAST tool is. You're not going to find very much, right? Because most of that code is the library, it's the framework itself. You've got a bit of decorator code and a bit of setup. You're not going to find much there. When those microservices are composed as a series of services that are interconnected, then you have a data problem. Then you have something that you would expect to see with SAST, but you don't. Right? So beware of that false sense of security that you've scanned all of your microservices with SAST and you found nothing. Just be wary of that. Question?
Is that mainly the fact that all vulnerabilities are actually logical issues?
Yeah,
Can you repeat the question for me?
Yes, so the question is, just Marcus, is that right? Yeah. So the question is it because the vulnerabilities are logical issues? Yes, primarily business logic, and those are ones that are always going to be hard to capture by tools. But in the case of SAST specifically, if we take in a source and a sink, which is how SAST is working, the problem is, if it's a monolith, the SAST tool has visibility of the whole model. When it's microservices, that connectivity gets broken. So SAST, and if you want to go try this, just try and check something up on SonarQube and have a look, and you'll see that you don't really detect a lot. So it gives you that false sense of security that you think you're more secure than you might be. Right, let's see how. So this is a good one. I'm going to take you to a couple of screenshots. So this is a global shipping company. This exploits happened in the UK. And what happened here is they had an endpoint where you could go and enter your tracking ID and you could get your status, standard kind of thing that you have on a shipping site. Now what they did is here they returned a little PNG of the location and some street names on it, which they thought, so security by obfuscation, they thought, well, nobody will get that address. Well, what people can obviously do is go and put that into the UK postcode system and they can get a range of addresses, like a dozen addresses. They then went and tried all those addresses with the tracking number. The tracking number was predictable and there was no rate limiting on that endpoint, so they could just zap through thousands of these things. They got the address. They could then go and get the full tracking information. So you see there, latitude, longitude, you're actually returning, they're returned in that. So what have we got there? We've got excessive data exposure. Right, so they returned everything, including personal details, phone numbers and everything. So that there's just like multiple levels of badness with that. So did we cover everything? That's pretty much what happened. Let's have a look at the issues and what they should have done there. So if we think about that design up front, well, that's the classic case of the data. They didn't understand that, whoever was doing that tracker thing shouldn't have been dumping PII information out there, right? They just didn't do the data design up front. Abuse cases, they never thought that somebody could guess the parcel codes. Certainly didn't think that somebody could guess the addresses. They relied on obscurity. It's pretty easy. This attack was quite easy to do. They could have easily tested that API was leaking PII information in the test stage. Right, it's pretty obvious what a phone number or something is, and lack of rate committing. So we've got a good assortment of things there. That's a great example. To be fair, they closed that out in like days, and then asked the researchers not to disclose it over the Christmas period, just in case, and then published it. This is a good example as well. This is a campus access control. Somewhere in the US, little phone app that you have, got the little release locks on the doors, campus control. So the guy he didn't like the app, right, before being here. We didn't like the app, so he thought, I'll write a little Apple script or something to be able to automate unlocking my doors. So he started reverse engineering the APIs. And he discovered that it relied on a username. And of course, he was on campus, so the usernames were now suddenly very predictable. In fact, he had a global directory of usernames, so he just sat through the usernames and then found that there was no authentication. So as long as you had a valid username, it authenticated you. So he got access to that. What else did the API do? It relied on getting a geolocation from the mobile device that you were actually near to the door. Did it ever validate that on the mobile device? It didn't, so he just submitted where he was trying to unlock, and then suddenly had a digital master key to unlock the entire campus. So broken function level, because what they were able to do was by switching out the IDs, you were able to access other people's data. No authentication, never mind broken, just none. They allowed the user to basically fake the location, which is just bizarre. And then the whole disclosure and release process was abysmal. I don't think they ever fixed this issue. I think it's still out there. This is a good one. This is a UK microbrewery. Let's go to the... Yeah. So this one, this token management stuff is like super hard, right? Oh, this is very confusing. Why not just code them into your binary like these guys did? Right? So they coded the dev prod and QA tokens into the binary. Obviously, people just reverse engineered that. Trivial to do. Whatever else coming out of that API, all sorts of PI. You just go back and remember what the other issue was. So there was something else where, they had to guess other customers' IDs, and then they could do Bola and get other person's accounts, and then they could also go and request beer discounts. So they basically worked out a way to print free beer tokens. So the main lesson here is if you're doing stuff like handling keys and tokens and that, don't go and invent your own. And definitely don't put them in the code. We've got OAuth 2 for a very good reason. Won't do these things in standard ways. Needless to say, these guys did respond really quickly because, they see
free beer is high impact.
Right. Now, if we printed free beer, these guys very nearly printed free money. Right? So this is a cryptocurrency. This is like the best example of Bola ever. So the story goes something like this. There's a crypto trading platform that allows you to trade. It allows you to have different currency accounts. The way it works is you have to do a setup. You put funds, you put £100 in one account, and then you have a euro account which has no funds in it. You start the transaction, you start the purchase, and then at the commit phase, where it's given you the object which is your pounds account, you switch that out, you give it the euro account, which has no money, and it still does the purchase. Right? Because what have they done? That's Bola. That's the best example of Bola ever. Look at the bug bounty, $250,000 that guy got. These guys fixed that issue. He tried to contact support. They didn't respond. He tweeted it. And about a minute later, they went in and they had fixed it within about 3 hours. So both the researcher and the platform did a superb job there, because we were about to create a black hole there, I think. That's the best example of Bowler ever. What did they do? They set it up, they made a sequence of calls, they got all the objects, and they did the final call that said, right, commit, but they never checked those objects. They just trusted user input, right, by another name. So that's...
Was that FTX or Genesis?
It was...
Can you repeat the question?
Sorry. It was FTX or that one?
Was it FTX or Genesis?
Genesis, no, it wasn't. This was Coinbase. Yeah. That is a case of, stuff happens. It was a relatively minor error that they made, but obviously with some fairly dramatic consequences. I think a bit of threat modeling would have found that for them. Right? This is a great one. This is a great one. I don't link the article, which is a shame. I'll put it in my LinkedIn and I'll tweet it, because the article is probably the funniest bug write-up I've ever read. I reread it sometimes because it's that good. Dating application. Well, let's have a look what happens here. So, one of these Tinder, Bumble, whatever the type thing is. The idea thing, you've got a list of people, swipe left, swipe right, people that you've connected with. They appear in a little JavaScript preview screen, and in there they put their location. But look at the location that they're returning. Right, look at the distance. That's some pretty good precision on that. Right, so they were returning literally the square inch they were standing on. And then they found that he could, if he found 3 people who were near enough to each other, we've all done a bit of trigonometry, quite easy to then trilaterate and find the person's exact location. Right, so what have we got here? We've got security by obscurity. We've got client-side protections because the locations were hidden by the JavaScript. But of course, they could find the JavaScript when they looked at it. And excessive, that's not quite excessive data exposure, but it kind of is. So what they did is they then only gave 1 point of precision. But there's another, but what they did is they then screwed up the rounding. So they were able to predict, I can't remember what the attack's called. It's like a binary search. You go up, down, till it flips. And that tells you exactly what the number was anyway. So, but it's a superb, absolutely superb article on all the issues that they had. Threat modeling, or just like a little bit of, brain power would have helped somebody who knew like triangles would have found that one. WordPress. So this one was a plugin that, this is an example I gave, it took, if anybody was logged in, never mind if they're running as an admin user, it bypassed that entirely. They also have a catch handler where they defaulted to validate instead of invalidate, so insecure defaults. And then obviously anything that's a WordPress plugin is basically running as root on that. But also, you see, the other thing with this one is that's interesting is those functions, like in WordPress plugins, if you know what that architecture looks like, there's a method called validate, right? That should give you a clue that that's quite an important function. So really, go and review that thing. Hand review that piece of code, right? Really understand what's going on there. You don't have to review everything, right? But just review those, and particularly look for changes, look for people getting that thing wrong. Just conscious of time now, I'm going to, because I want to get on to some of the best practices in that. That's a good one as well. Load balancer, a well-known enterprise load balancer had a RTE, and they got themselves, it was through code injection on an unpublished default enabled endpoint. Can we share the slides, by the way? I see there's a means to share the slides. Because I'll put this on, and I'll update and put links to all of this. Home route to these are these little, we've all seen this, I'm sure we've done labs where, we do this kind of thing. thing. This one also had a CSRF in it, so that people were able to use a slash bin endpoint to do things. I'll move through this. This is also a good writer. This was a smart scale. This was a good one because they had 3 or 4 unrelated. They had a bit of Bola, they had a bit of, let's see what they do here, leakage exposure. They returned the refresh token, which doesn't seem like a great idea. And a number of these unrelated things, and then the attacker was able to just string the things together and then go and do complete account takeovers. That's a CI/CD platform that shall remain nameless. The issue still exists with that. They're dumping tokens and keys out of the logs. Still in they claim it's a feature. Right, so top ranking issues on our count. Bola, it is the number one, and rate limiting and excessive information exposure probably comes up. So 15 minutes, I'm going to leave time for questions, but if you do want to jump in now. So I can go through, what do we want to do at this point? So I want to talk about threat modeling in APIs. So I'm doing some work with Areas Risk on their community project, getting an API threat modeling, I can't remember what the technology is, but the module or whatever, to be able to threat model API-specific issues. Right, I don't think it needs to be terribly formal either. I think many of these things, where somebody had just gone, you know what, how should we go postcode prompt reverse engineer to an exact address? Think like an attacker. So this is mainly from our developer frames, that's the number one thing that people say to me. So I run this, so I do the webinars and stuff for 42 Crunch. We have people say the most in-demand course that we have is people wanting to do hacking courses, and they want to learn what are the hackers doing. So if you develop and you're developing defensively, just think like, there's a story that goes behind that last graphic, but I can't remember what it is, so let's move on. Data, so APIs are about data. Expose too much data, think about what your data is. If you don't know the provenance or the regulation behind that data, don't randomly put it in an API. I'm going to find out, get the proper data controls over that. Rather expose less than more. You expose too little, somebody can always go and say, hey, I need this thing, then enable it. So a couple of powerful things. So JOT, Philippe Durek is always talking about JOT validation. Right, people still getting this wrong. There's still JOT tokens with no encryption. There's still people who implement their own, they don't validate the JOTs. You know, this happens all the time. Those are easy things. Sorry. Let's do a picture of that. Those are easy things to fix, right? JOT, it's all, there's recipes for this, there's lots of guides on JOT things. You can code most of that as well in scripts that can test and validate that. This is also courtesy of Philippe. Authorize every function endpoint. So the broken functional authorization, so they're explicitly going to state that permission, right? That, so that when somebody reviews that code, they can go, really, would that have to check that he has the right to delete task? Well, obviously, the method's called delete, so we should check we have that permission. Make it explicit, because also those things in code reviews would be very easy to find. Yeah, this is a good one as well, because how do functions in like WordPress plugins end up being unauthenticated? Because somebody copies a piece of code that doesn't have an explicit unauthenticated decorator, and then doesn't realize that they're actually inheriting a copy-pasting a piece of insecure code. So make it explicit, so when somebody looks at that code, they'll go, no, that's not what I mean. So this data issue with the excessive data leakage and mass assignment, where we assign data, the main culprit there is your ORMs, right? It's your object relational mappers. Right? They're helping, they're allowing you to write great code really quickly, and they're doing all the dirty work. But what they'll do is, an ORM, if you give it a field and try and do an inference on that name mapped to a field, that's not the behavior that you want. So use an API sort of, data bridge between that, where you very explicitly manually map all of those fields over. I know it's a pain, I know you're hating copy-paste code, but it's far safer than the alternative.
There are easier ways to do this, but you don't have to actually copy all of the fields one by one. But there are technologies to copy specific.
Okay, so the question is, there's better ways to do this. You don't have to do that. You can have decorators that say don't. Yeah.
You do have to have separate front end and back end.
Yeah. Yeah. But your ORM is one of those bad ones there. Unused methods, right? We see this quite a lot. People code up, they'll expect to do a post, and they'll forget that they left the get method or the put method in there. Make sure that you explicitly qualify and enable the endpoints that you're expecting to handle that makes sense in your context. Certificate pinning, we don't need to do that. All of those things about broken authorization, all of those things normally have their origin in somebody trying to write and implement their own authorization code, right? It's a spaghetti, it's just crazy loops of things, and what happens when people do that? They make mistakes, they forget to do this. So use a standard framework. There's great standard frameworks, there's Open Policy Agent, there's any number of proper ways to do this. Use those rather than inventing your own. SendGrep, right? We're all fans of SendGrep. All those JWT things that we found, there's a whole great rule pack on SendGrep. It can take you through and help you find out how all your, the standard things that people get wrong with JOTs. You can go and look for missing decorators or hard-coded secrets and the like. We spoke about frameworks that you use. Node Express, I think, has some pretty bad security faults. Right, it enables success if it puts default handlers in for unused verbs, which is probably not what you wanted to do. Right, so just make sure that you know what your framework is doing and go and turn off all the stuff, basically just harden it. Did a webinar with Jim Manico 2 weeks ago talking about CSRF, and I actually said to him in the prep for the webinar, I said, Jim, I haven't seen CSRF on an API for ages. I get why if you're using cookie-based calls on the back end, sure you can get it. Then literally the next day, these guys, Fortbridge in London, found Plesk and things with a real proper complete takeover on there via CSRF. So there you go. So don't forget those old favorites we already seen command injection in the router. So runtime stuff, what can we do here? So not quite the product pitch, but we've got a bit of our rate limiting. There's good strategies for rate limiting, adaptive, all sorts of things that you can do to get rate limiting to work properly for you. You can do it at multiple levels as well, to gateway and to your individual API. JOT token validation, your gateways can do transport layer security enforcements. Use an API firewall can do your JOT validation for you. Right, so it does that and throws that for you, and it's done it in a kind of hardened, approved way, and it also does it way quicker than you'll do in code. Security headers, those are easy things to enforce and find that they're there in the transport. Get your APIs, one of those things we spoke about is what you can't see, you can't protect. Not many people, a lot of people aren't really getting API layer 7 data into their SIM and SOC. We're working on some research that we've got going on to detect what bots are doing with APIs in the wild. So good stuff to go and read. That book if you want to get into hacking APIs is awesome. It's also got a really good free entirely free laboratory at ESEC University, something along those lines. Really, really good course. APIsecurity.io newsletter. I've got a book coming out in the new year. I have a chance to finish the last half of it on defending APIs. So we'll be fleshing out a lot of what we've looked at here. So that's the presentation. I know we've got a few minutes now. There's probably, hopefully, going to be lots of questions. No.
Here's a question. Not so much a question as it more. Earlier this year, the Untitled Chapter had a webinar on API security. You can find the slides and the recording of the webinar on the website of AUTH.
Brilliant.
Any questions for Colin? All right, you guys are
Yeah, so you talked about validating your job tokens on the edge, right?
Yes.
Using a standardized method. This was a topic within the organization I work in. The engineers suggested they're not doing it on the internal network anymore, and I'm thinking, that's a bit insecure because if you have a server-side request forgery or anything like that, you're going to be toasted, right? So how do you feel about that?
No, I think that's a valid point. I think it depends on what the job token is claiming, right? I know. Let me think who the guys are. Curity.io. They're pretty big on. I know there's various good patterns for the way that you would delegate that job token authorities. I don't know a lot more detail on that, but I know that's quite a topic where they're calling a token exchange, where your perimeter will exchange for a back-end access token. So I think that's a good point though. If you're doing it at the edge and then your internal is not protected.
Or stop using AWTs for something else design.
Yeah. All right. Any other questions? You want to give Colin a big applause?